A strange little ship crossed the ocean in 1970, oddly narrow, oddly short. Painted right across its hull the words "Cut Here." Workers had built this piece on purpose, planning to slice it apart the moment it reached Pennsylvania. This became the first 1,000-foot freighter on the Great Lakes, a genuine engineering triumph, and once it arrived, it could never leave the lakes again. Quick question, before we dive in, where are you watching from today? The ship was built in 3 pieces on 2 different bodies of water, and it still wasn't the strangest part of the story. By the mid-20th century, America's steel industry needed iron ore delivered at a scale earlier generations of shipping simply couldn't match. Much of that ore now came as taconite, low-grade rock processed into small, dense pellets. Mills along the Great Lakes consumed enormous quantities of it, and moving that tonnage efficiently across open water mattered enormously to the entire industry. For decades, though, one bottleneck limited how large any Great Lakes freighter could realistically become. The St. Lawrence Seaway, connecting the lakes to the Atlantic Ocean, ran ships through a series of locks capping vessel size at 740 feet in length and 78 feet in width. Any ship built larger than that simply couldn't pass through. This physical ceiling shaped nearly every freighter design built for the lakes throughout the mid-20th century. Something changed in the late 1960s, though. The Poe Lock, part of the Soo Lock system at Sault Ste. Marie, underwent major reconstruction, emerging with dramatically larger dimensions than anything the Great Lakes had previously offered. Once finished, the new Poe Lock measured 1,200 feet long and 110 feet wide, a truly massive jump compared to older lock infrastructure throughout the region. This single upgrade changed what shipbuilders could theoretically attempt. A vessel far larger than any existing Great Lakes freighter could now physically pass through the busiest connection point between Lake Superior and the lower lakes. Opportunity like this doesn't stay unnoticed for long within an industry constantly searching for efficiency gains. A ship twice the length of typical freighters could carry dramatically more cargo per voyage, fewer trips needed to move the same total tonnage. Fewer trips meant lower operating costs. Lower operating costs meant genuine competitive advantage for whichever company figured out how to build and operate a vessel at this unprecedented scale. Steel companies throughout the region understood the stakes clearly. Whoever built the first ship capable of using this newly expanded lock stood to gain real advantage over competitors still relying on smaller, less efficient vessels. The theoretical opportunity was obvious enough. Building an actual working ship at this size, though, presented challenges nobody in Great Lakes shipping history had ever needed to solve before. Nothing this large had ever operated on these waters. Every existing shipyard, every established construction method, every assumption about how freighters got built throughout this region, all of it had developed around ships considerably smaller than what this new opportunity now demanded. Somebody would need to figure out how to actually build a 1,000-foot ship for waters that had never seen anything close to that size before. The new lock could handle a giant. Building one and getting it there was an entirely different problem. Litton Industries recognized this opportunity early, moving decisively to position itself for exactly this emerging market. In the late 1960s, the company constructed an entirely new shipyard at Erie, Pennsylvania. Unlike older, more traditional facilities scattered throughout the region, this new yard incorporated modern automation specifically designed around efficient large-scale ship construction. Litton's timing aligned perfectly with the Poe Lock's expansion. Building this specialized new facility positioned the company to capitalize immediately once the enlarged lock opened new possibilities for vessel size throughout the Great Lakes shipping industry. In 1968, Litton secured a contract with Bethlehem Steel Corporation. The agreement called for something genuinely unprecedented, a 1,000-foot vessel built specifically for Great Lakes service. Bethlehem Steel brought marine consultants and designers of Cleveland into this project too, working alongside Litton to develop appropriate specifications for a ship at this dramatically expanded scale. Planning proceeded with real momentum throughout this period. Everyone involved understood they were attempting something entirely new for the region, a vessel considerably larger than anything currently operating throughout Great Lakes shipping. Here's where the project ran directly into an obstacle nobody could simply engineer around through better planning alone. Erie's shipyard sat directly on Lake Erie, connected to the broader Great Lakes system. Getting materials and components to this specific location required navigating existing waterways, including, critically, the St. Lawrence Seaway itself. If you're finding this story fascinating, hit subscribe. We cover engineering puzzles like this every week. That same seaway, remember, capped vessel dimensions at 740 feet long and just 78 feet wide, considerably smaller than the full 1,000-foot, 105-foot wide ship Bethlehem Steel actually wanted built. This created a genuine paradox for the entire project. Building the complete vessel anywhere with direct ocean access meant somehow transporting that finished ship through locks specifically too small to accommodate it. Standard shipbuilding practice simply couldn't solve this particular problem. You couldn't build a 1,000-foot, 105-foot wide vessel at any ocean-accessible shipyard, then expect it to reach Lake Erie through waterways physically incapable of accommodating something that large. Engineers needed a genuinely different approach, something that acknowledged this physical limitation rather than simply hoping to work around it through conventional methods. Whatever solution emerged would need to somehow deliver a ship too large for existing locks, using exactly those same restricted waterways as part of its construction and delivery process. You couldn't build the ship at full size and get it to the lakes, so engineers decided not to. The solution that emerged genuinely surprised people familiar with typical shipbuilding practice. Rather than attempting to transport a finished full-sized vessel through restrictive locks, engineers decided to build only specific sections at full size initially, keeping other sections deliberately smaller until they'd already cleared the seaway's physical limitations. Ingalls Shipbuilding, located in Pascagoula, Mississippi, took responsibility for constructing the ship's bow and stern sections. These pieces would eventually house the pilot house and engine room respectively, critical functional components any working freighter genuinely needed. Here's the clever part. Workers deliberately built these sections at just 75 feet wide, considerably narrower than the ship's eventual full 105-foot width. Why build sections narrower than the finished vessel actually required? Simple. A 75-foot width could successfully pass through the seaway's locks, while the full 105-foot design absolutely could not. Once welded together, these narrowed bow and stern pieces formed a single combined unit, officially designated Hull 1173. Workers nicknamed this strange-looking assembly Stubby, an entirely fitting name given its unusual proportions. Stubby measured just 182 feet long, genuinely tiny compared to the eventual 1,000-foot ship it would eventually become part of. Picture something resembling an oddly compressed, incomplete vessel, missing its entire middle section entirely. This unusual construction traveled from Mississippi through open ocean waters, eventually reaching the St. Lawrence Seaway itself. Given its deliberately reduced width, Stubby successfully passed through locks that would have completely blocked the full-sized finished ship. June 1970 brought Stubby to its intended destination, Lytton's new shipyard facility at Erie, Pennsylvania. Workers there faced an unusual task waiting for them. Painted directly onto Stubby's hull, quite literally, were instructions reading "Cut here," marking exactly where this strange combined unit needed separating back into its original bow and stern components. Following these painted instructions precisely, workers sliced Stubby apart into two distinct pieces once again, the bow section and the stern section, exactly as they'd originally existed before Mississippi shipbuilders had temporarily joined them together for transport purposes. Consider the genuine audacity behind this entire approach. Engineers had deliberately built a ship in a way specifically designed for later disassembly, understanding from the very beginning that this awkward, seemingly counterproductive step represented the only realistic solution to their fundamental size problem. This wasn't a mistake requiring correction. This was intentional, careful planning executed precisely as originally designed. However strange the underlying concept might have appeared to anyone unfamiliar with the specific physical constraints driving this unusual decision. Cutting the ship apart was strange enough. What happened next made it whole again, and finally too big for the route it had just traveled. While Stubby made its unusual ocean journey, workers back in Erie had been busy with an entirely separate piece of this puzzle. An 18-foot mid-body section, the ship's massive cargo-carrying middle portion, had been under construction directly at the Erie Shipyard throughout this same period. Crucially, this mid-body section faced none of the size restrictions that had shaped Stubby's unusual dimensions. Workers built it at the vessel's full intended width from the very beginning, all 105 feet, without any need for later modification. Why the difference? This section never needed travelling through the seaway's restrictive locks at all. Built directly at Erie, positioned entirely on the Great Lakes side of the entire waterway system, it simply never encountered the same physical bottleneck that had forced Stubby's narrower construction. This staged approach reveals something genuinely clever about how engineers had approached this entire challenge. Rather than treating the seaway size restriction as an obstacle requiring some universal workaround, they'd identified exactly which specific portions of construction actually needed passing through those restrictive locks. Only the bow and stern sections required that particular ocean-to-lakes journey, since specialized shipbuilding capacity for these complex components existed primarily at established coastal yards like Ingalls. The massive mid-body section, essentially a long, relatively simple cargo hold, could be built anywhere with adequate facilities, including directly at Erie itself, completely bypassing any need to navigate restrictive waterways at all. This distinction mattered enormously for solving the broader puzzle efficiently. Building everything at full size simultaneously, then hoping to somehow transport the complete finished vessel simply wasn't viable given existing lock dimensions. Instead, engineers split their approach strategically. Build the complex components requiring specialized expertise wherever that expertise already existed, accepting temporary size constraints purely for transport purposes. Build the simpler, larger midsection directly where its final width wouldn't cause any transportation problems whatsoever. This solution required genuine coordination across multiple facilities, separated by enormous distances. Mississippi and Pennsylvania sit roughly 1,000 miles apart. Yet workers at both locations needed their respective components ready for eventual assembly at precisely coordinated timing. By mid-1970, all the necessary pieces had converged at the same location. Stubby, freshly separated back into bow and stern sections following its unusual journey, sat ready at Erie. The 18-foot mid-body, built entirely on site, stood ready alongside it. 3 separate pieces, constructed using 2 genuinely different approaches, based entirely on whether each specific section actually needed passing through those restrictive seaway locks or not. Now they had 3 sections in the same place. Putting them together for good was the last real test. Built in 3 pieces across 2 different waterways, launched through a trick of undersized construction and permanently too large to ever leave the lakes they were built for. These freighters remain proof of what determined engineering could accomplish. If you enjoyed this story, hit subscribe for more construction history.